Thank you for joining this glTF virtual meetup. Joining us for today are Gustav Sterbrant from Snap, David Prinz from INNEO Solutions, and Brian Wachanga from Klurdy Studios. First, a couple of housekeeping items. If you have any questions during the presentations, please ask them during the Q&A feature located on your Zoom toolbar at the bottom of your screen. We will address all questions during the Ask the Expert session. We are recording this webinar and we'll share the link along with the slides and the recording shortly after. At the end of the session, please complete the short survey form to help us better design future events. With that, I'll hand it over to Gustav Sterbrant from Snap. Gustav?
Hello, everyone. My name is Gustav. I work for the PlayCanvas team at Snap, and today I will be talking about our road to glTF compliance. For those of you who may not know, PlayCanvas is a 3D content creation platform for the web. It comprises a set of tools. We have a fully collaborative browser-based editor, an open source model viewer, an open source runtime, which is an engine, and more. PlayCanvas uses glTF as its primary asset format. Last year, we added support for all ratified extensions. We also added support for these materials in our editor, which means that we also added full support for texturing, texture transforms, and tints. We also added support for Draco compressing meshes in editor. And the different extensions that we added support for includes sheen, iridescence, rough refractions, volumetric refractions, as well as material variants. We also added support for importing GLB straight in the editor. It's a very simple process. You simply just drag and drop the GLB to the PlayCanvas editor. PlayCanvas will then start loading the different assets, the textures, the meshes, the materials. And when it's done doing so, it will create a template asset that you can use to instantiate the GLB with all the materials applied. The GLB can be disassembled into its constituent parts. And because we fully support glTF and all the extensions, we allow for the user to change the materials as well. In this case, you can see me changing the different iridescent parameters on the iridescent lamp example. We can go one step further, which is to completely replace the material on one of the parts of the GLB. To support the KHR lights punctual extension, we also had to do a little bit of extra work. We had to add support for physical light units in the engine. This means that instead of representing lights as an intensity value, they're instead represented by a more physically correct unit. This allows for a very wide range of light intensities in the scene. In the images you see here, the lights have the exact same intensity, but in the right, we disable the skylight and change the camera exposure parameters so that we can see the area light and the two spotlights illuminating the cube. To accommodate for physical light units, we also had to implement physical camera parameters as well. So instead of having the exposure value on a camera controlled by a simple value, they're instead controlled by aperture, shutter, and ISO values instead. This means that you can model an actual physical camera and it should match actual physical light intensities in the scene. We also released a new model viewer, which we are proud to announce. The glTF 2.0 model viewer supports all the extensions just as the engine does. It's completely open source and it's available on GitHub. It can demonstrate well the GLB node hierarchy, can play animations and morph targets, and it also supports a very high resolution viewer. We obviously have some future plans for PlayCanvas. One of the things we noticed was that a lot of the glTF materials have quite unintuitive parameterization. So we want to supply a set of sample materials that users can just apply and change afterwards. We also want to support more control over the Draco compression process, which we will be adding to the editor. We have implemented a very rudimentary glTF exporter, which is just the meshes right now, but we want to extend that to support materials and extensions, skins and animations as well. This means that you will be able to take a PlayCanvas level and export it as a GLB and import it in another GLB editor if you like, or give it to somebody else. Here are some links that I list. The first one is to get to use PlayCanvas in the editor and your live projects. The center one is our open source project of the engine. So you can go and have a look at our different PRs and whatnot, and you also contribute yourself if you're keen. And the bottom one takes you to a live example of PlayCanvas loading and rendering a bunch of different GLB assets. And that's all for me. Before I end, I would just love to make a shout out to all my colleagues who have helped me with this presentation, as well as obviously working with me on PlayCanvas. Thank you very much.
Thank you, Gustav. Next up, we have David Prinz from INNEO Solutions. David, go ahead and share your screen.
Thanks a lot. Hi, I hope you guys can see my screen.
Looks wonderful.
Great. Thanks for having me. My name is David Prinz. I am the head of development at the digital reality department at the INNEO Solutions. Today, I have the pleasure to have a presentation about our Web3D editor and about how to get 3D CAD data ready for Web3D using it. I've been at the INNEO working on this project and other projects since 2016. My team and me, we had a lot of fun using Unity 3D and creating VR experiences and augmented reality applications when the newest headsets and devices came out. And since a few years, we've been developing this web-based 3D editor that has its focus on creating and optimizing and distributing 3D experiences for our B2B customers. To begin the presentation, first of all, I go to the question, what is NeoSpace, or maybe why NeoSpace? In our opinion, the benefits of interactive 3D technologies are often limited to a privileged few. The reasons are complex software systems, incompatible formats, deficient user experiences that make the field of 3D a domain for experts. Small and medium-sized enterprises are often unable to hire specialized 3D experts due to the shortage of specialized workforces. Our software NeoSpace aims to make 3D technology accessible for a wider audience. We do so by creating innovative and smart functionalities and user-friendly workflows to enable non-experts to create, use, and distribute interactive 3D applications. By doing so, we not only enable a wider audience to use 3D, but we also make the use of 3D less time-consuming for already existing 3D users. And to us, it's very important to choose sustainable technological components like glTF and WebXR. Summed up in 2 sentences, we believe that the digital future will be a 3-dimensional one, and that's why we democratize interactive 3D technologies for a wider audience. Again, what is NeoSpace to our customers? Most of our customers are in the B2B, in the industrial sector. They are in need for a simple software with smart features and streamlined workflows for a steep learning curve. Our software is very much process oriented. It's designed for the integration in existing processes and systems like PLM systems, learning management systems, and so on. And we also cover a wide range of different use cases in sales, marketing, service, and so on and so on. To have a look at the challenges our software faces, in our opinion, there are three kinds of challenges. First of all, formats and technologies. Our software supports a wide range of different formats, of different very important formats as well, like the glTF format, for example, which is the first-class citizen in our software. So the whole software NeoSpace is based on glTF as a primary working format. We utilize different technologies, of course, like WebGL, WebXR, the Draco compression, which is great, but also import different other formats. And this is very important for our customers to get started with the software and distribute experiences later on. Also, a very important subject is optimization, the performance. Our models need to be good in terms of loading times. The loading times need to be short. There can't be any stuttering performance. We need smooth FPS, and we need to keep an eye on the runtime usage for our models. And the third challenge would be the creation and maintenance of content. Not all of our customers have fancy or useful 3D animations. Maybe they need to create some. They need to do the materialization as well, and that's something our product also delivers as a functionality. To give a brief overview over some use cases and references, we are active in spare part catalogs, virtual showrooms and trainings, just as virtual trade shows and events. We offer a web viewer for the easy integration of our 3D models into websites, and also so we deliver the necessary formats for augmented reality presentations for sales. We offer user interface templates for the deliverance of step-by-step manuals in the field of, well, digital manuals and service. And we are also active in the field of product configuration. I brought with me three quick examples of some of our customers and how they use our software. First customer would be Xtech. They integrated our NeoSpace web viewer into their website and loaded the 3D model from our cloud. As you can see, we have different interactive functionalities in the software, like some annotations, like different variants of the same or different products, and multimedia files and things in the annotations. That would be the first use case. The second use case would be Doka. Doka is using our software to create and deliver step-by-step manuals for their service portal. As you can see, those step-by-step manuals are basically 3D models that are enhanced with suitable UI around them. You can do various things. Each step has its own 3D model and its own 3D animation, and you can also add different multimedia files or even add multiple 3D scenes to one digital manual. And the third use case would be Trumpf, which the project Trumpf did with our software is a virtual showroom that they created for a briefing of an actual physical event. They put this step-by-step presentation of their actual exhibition into e-learning, so into a learning management software tool for their customers to go through and have a virtual tour through their booth. So next, we come to the product showcase. I will be quickly demonstrating the basic workflow on how NeoSpace works. So what we see here now is the tool. What I do is I drag and drop a step file into the tool. We have different, well, tessellation levels, import quality levels. And after a short waiting time, we have the product in there. We have different settings in this editor, like shading settings, like post-processing settings. We can import different environments, like, for example, this HDRI that I have found somewhere online, which can be imported as a lightning source or as well as a background. We have this neat dome functionality that distorts the HDRI in a manner that it actually looks like it's the actual environment of this, which adds up really in an optical sense. And there are, of course, different other settings in our software. As you can see here, I choose different lighting settings. I can choose different lighting independently from the environment. I can delete or edit the whole 3D object in here. As you can see now, I choose to take one of our prefab materials and add it to the model for a glass-like look of the exterior. I can do so with existing materials as well, like this one, for example. I think it's too dark, so I lighten it up, maybe give it another color. And I shortened up this video a little bit for you, so I'll be able to stay in time. Typically, after our users are done with the materialization, they go into the stickers module to add up some logo to bring the right corporate identity onto their products. So I've just chosen to add a NeoSpace logo in the same editor. And after we are done here, we go to the annotations module, which is a very nice functionality as well. Here you can add additional information to the product, just like so. Add up text, for example. You can add up different multimedia contents in here, like text, images, add an iframe, for example, of other web applications, a button, a YouTube video. So there's a lot really that you can put into these multimedia annotations for additional information around the product. Once our customers are done, they can go to the optimize section to get a closer look on the performance and the rating of their model and maybe tweak some options to get it an even better performance. We have this really nice functionality, which is called the Web Performance Score. This is a AI trained score rating of your 3D model that takes in consideration different attributes of your model. And we have this basic optimization that goes with one button click that adds up Draco and does different other optimization things with your model, really, to bring down the whole size. In the end, we only have to distribute it. We have a direct cloud connection here to the INNEO cloud. We can change different settings on the uploading and choose if we want to deliver a USDZ file or not. And the finished model then in the browser looks kind of like this. You guys can feel free and take your phone and scan the QR code if you guys want. This is also a very nice thing about it, that you can distribute it very fast and share it with anyone you like. We have different predefined user interface templates and functionalities that you can use, like a first person mode or this inspect mode, for example, that I'm about to show. So you have the hierarchy still present in your browser. If you choose so, of course, you can also deactivate that for distribution and show and hide different things that really adds up to different use cases of our customers out there. So far, so good. Of course, this is not everything. This is just a basic workflow. There's much more functionality in the tool, but I think we need to stay in time. To show you guys some more of the functionality of the tool, I've chosen to give you a brief overview of the last two releases we had, the release 2.13 and 2.14. And I'll start off with 2.13 and the filter options in the model optimization tab and module. Again, a short video here. As you can see here, I've chosen one of the pretty heavy CAD models of our customers, and I can go into the optimization tool here and choose to use the filter options to maybe select some of the most heavy or maybe the small parts of the model and then reduce them or delete them. This is exactly what I'm doing at the moment in this tool. I'm selecting the smallest part. I can also isolate this view here. That's what's new about that functionality. And when I have made sure that there is nothing here that's really important for my product demonstration, I can just tweak a little bit and then delete those. Also, the next thing I'm gonna show is how to filter for the most heavy parts of a model, because to bring down the model size further. So as you can see, you can just grab this slider here and you will select the most heavy elements of a model in terms of poly count. And again, you can then select the reduction functionality to bring down those. I'll skip the rest of the video and I'll go to the next functionality. In release 2.14, we had 4 major functionalities: model performance score, interactions, a scripting module, and different play modes. I'll quickly show these. As mentioned before, we have introduced the model performance score. Before the model performance score, we were only able to get an insight on polygons, on meshes, on materials and textures. And as some of you guys maybe know, sometimes it can be very intransparent on what these numbers mean. So we introduced just one number, the web performance score, that gives you an insight on how good your model will perform on the web browser. You have different insights here, like the FPS score, for example, a loading time score, and also a score on the runtime usage, which is also important, especially if you want to deliver 3D assets on Safari on iOS, because Safari is a little bit difficult in terms of runtime usage. As you can see here, I'm going to optimize some things now. The textures, for example, I'm just resizing all textures at once, and I've already brought up the score from 47 to 59. And again, if I am deleting some small parts in here, like this, in the end, I will have a much better model performance score than in the beginning. Now we're at 86, which is a very nice score. It's in the green region. And this is what's very important to our customers. They don't want, or they can't learn all insights on how to reduce models. They want a unique KPI that they can orientate around, and that's what a model performance score does for them. And again, next functionality, interaction buttons. I've just shown you annotations in the basic workflow. The interaction buttons are logic-based annotations. Basically, what they do is, if you click on them, you get a nice animation just on them. This is something we store in the glTF file as well. So this information is in the extras region of the glTF file. And that's something we also added to our product just recently. Next functionality would be the scripting module. As I just stated earlier, for our customers, it's very important to stay process orientated. In this brief video, we show an automated materialization of a 3D model. One of my colleagues supplied me with a script that's called swapmaterials.javascript. And in this script, he'll just identify some parts based on their name and materialize them with a black material. And that's the outcome of the whole story here. And at last, I can show you the play modes. As I just mentioned, our editor comes with different user interface layouts and modes. In this mode, I'll activate the inspect mode. I'll activate a show reset camera button and the first person mode, and I'll just update the model I've just uploaded. And as I do so, the changes come into place. And as soon as it's uploaded, I can see the different user interfaces up here. Press refresh of the site. There we go. And now we have the inspect mode, the overview, the first person, and also on the bottom left, the camera reset button available. Camera reset button, as you can see, resets the camera, does what his name tells us. And I've already shown the inspect mode in the basic workflow demo. The first person mode and the overview mode gives us the possibility to walk around or to walk within a 3D model for virtual tours and for the exploration of large models like whole buildings and things like that. Those were the most important functionalities so far. Of course, there is a lot much more to it. So far, thanks a lot, and I'll hand over to the next one. Thanks a lot for having me.
Thank you, David. Next up, we have Brian Wachanga from Klurdy Studios. Brian, if you want to go ahead and take the screen.
Hello, are you able to see my screen?
Yes, it looks great.
Awesome. Thank you so much for having me. My name is Brian Wachanga, and I'm the founder of Klurdy Studios. And today I'll be showcasing how to create immersive shopping experiences using voice commands. As a background of myself, I'm a computer scientist, but I really love design. So in the last 10 years, I've been very interested in technologies that bridge between design and data science. So how do you apply like computer vision algorithms and natural language processing to make better user experiences? So for today, the agenda for today, I'll try to keep it simple. The first thing I'll want to showcase an understanding of the reality virtuality continuum. And then we'll explore some of the benefits that come with using voice user interfaces and its place in 3D shopping experiences. And the last part, we'll look at some of the different AI tools that can be used to build these voice XR experiences. So as we all know, we have experienced some form of device that can be able to load 3D content. So in this reality virtuality continuum, you'll see that some of the devices are on the far left. That's where the physical reality is, and we have the watches, the smartwatches, and the phones and the laptops. And you find that these devices are actually connecting users to the physical reality. And as we move on to the far right, we go through from physical reality, and then we start experiencing augmented reality through PCs or through phones or browsers. And then as we continue way further across the scale, we start experiencing augmented virtuality. That's where we start experiencing things like smart glasses or some form of headsets. And then at the far left, at the far right, we experience virtual reality, and that's kind of like an enclosed virtual world through VR headsets like Oculus or the Vives and the likes. But one thing all these devices have in common is, one, they can be able to load 3D content using glTF formats, and they have a form of a speaker and a microphone. So some of the benefits of using voice is, number one, voice can actually help you lower the adoption barrier. And by this, we mean that instead of just having a user experience where people can click around and actually perform tasks that your application does, you can also offer like a more natural interaction medium through voice. And most people can actually communicate through voice, and it's kind of like it has lower trainings, and better for people to adopt faster as compared to having clicks using a mouse or such. The second part is voice adds interactivity. So through voice commands, you can actually interact with the device. And by this, I'm sure most of us have used something like Siri or Google Voice, the one that you say, hey, Google, and then you can ask it to maybe schedule something on your calendar or something like that. The third benefit of using voice, it helps in multitasking. So for example, let's say if someone is performing a task in the physical world, let's say someone is cooking, they can still be able to actually interact with the application through voice, because now their hands are free, and but by talking to your application, they can actually also perform tasks while they're still continuing their tasks in the physical world. And the last one, and this is kind of like my personal favorite, is it provides accessibility. So you find not everyone is capable. So you find there are people who are actually being left out by technical products, and these are people living with disabilities. So you find people who are maybe are blind. They can actually be able to interact with your application through voice, because there will be need for screen readers and the likes. So before you actually create a voice user interface, there's some conversation design principles that need to be followed, which are basically like a set of ideas on how computers can socialize naturally and effective with people in the physical world. So the first part is it has to be interactive. So if you're designing a voice user interface, the user should be able to interact with your application. The application should be able to respond to the user, and it needs to be a back and forth. The second one is the conversation needs to be contextual. So maybe if you're building an application for shopping for fashion, you need to keep your conversation around the context of fashion and shopping and online shopping. The third one is it needs to be variable. So if someone interacts with, if two people interact with your application, it shouldn't be like hard-coded responses. So it needs to be feeling a little bit natural. The fourth one is it needs to be multimodal. So what this means is although voice can be a very good way of interacting with a computer, you should also leave room for other forms of interaction. So voice shouldn't be the only mode of interaction with your app. So you need to have like still use like mice or controllers and the likes. So for this, this is even a more natural thing even we see in the physical world, where if, like, for example, you're interacting with your friend and he wants to share how he had a really nice weekend, they still have to take out their phone and show you some photos. So we still need to have the conversation needs to be multimodal. So some of the use cases that we currently looked at in the online shopping world, and how voice can be used to actually provide a better user experience, is there are some quick tasks that we identified. Some of them can be like shopping controls. Like, let's say if you're viewing a product, you want to view like the different variations of that product. Maybe you're viewing a t-shirt that has a white variation and a blue variation. So you can interact with that application naturally through voice, just to move through the different variations. And actually this ties in nicely with the glTF, because now glTF has an extension, I think it's called like the materials extension, where you can actually save the different textures for one model in one asset. So it's basically like looping through the different variations in that model. And the second part is interactivity. So we realized also by doing our design research, we realized users need to actually get more information on clothes that they want to buy. So what we've been playing around with is we are creating interactive avatars that are AI powered, that kind of like act as shopping assistants. Also in terms of interactivity, there's product configurators. So here it's quite interesting because especially for digital clothing, you find you can use this generative AI, for example, like Stable Diffusion, to actually create like depth maps and textures for the 3D models. And all this is based on what the user wants to create. So they can be, they just use text to actually create the prompts that usually create these variations. And then the last bit is accessibility. So here it's helping people who have visual impairment issues. And this is a big thing because at Klurdy Studios, we have been trained by Meta through the Oculus Launchpad program. And one of the key things that is trained is most of the VR experiences that are being created are not being tested with people who live with disability in mind. So here for us, voice offers a very interesting use case for making our application accessible. So in terms of the application architecture, it's kind of simple on how it works. So the first part is when a user talks to the app, we need to do speech recognition. So through speech recognition, we are able to convert the voice to actually to transcribe the voice to text. And then using that text, you can run your custom logic just to understand what the different actions that need to be done. But also through this text, you can also pass it to like an AI or a machine learning model that can actually use to actually understand the text and also generate responses to the text. So there are two parts. So there is one of understanding what the user is telling the app. So for that, it can be translated to either an action. Maybe the user wants to add whatever the product he's viewing or she is viewing to the cart, or maybe they want to add more quantities, or maybe they want to check out the next variation or something like that. So that part is called natural language understanding, so NLU, but basically making sense of what the user is telling the app. And using that, when you use that response or that understanding, you can actually move a step further to actually generate text, which will actually respond to what the user wants. So here for natural language generators, there are things like ChatGPT. So ChatGPT it falls under that category where you actually ask it something and then it generates text back to you. So all of this can be integrated in an XR environment and be able to actually use an XR app using voice. So some of the AI tools that we've seen out there that can be quite useful in this, of course, there's ChatGPT for generating responses. Cohere AI is kind of like a competitor for OpenAI. They have interesting models. There's Meta's Wit AI. So this one actually, the Wit AI is quite nice because you don't need to have like programming skills. It's kind of like a no code solution, and it actually works. And then there's Stability LM. This is for like text generation. And then for images, if you want to generate textures for your 3D models, you can use Stable Diffusion. There's a plugin called Dream Fusion, which you can actually, if you give it a depth map of your glTF, they can actually generate textures based on what you tell it to do. And as you can see here, this image, as you can see on my right, this is actually generated by AI. So what we are trying to achieve is, as Klurdy, we actually create 3D experiences for fashion brands. We've been able to collaborate with companies like Snapchat, Meta, NVIDIA. But for this project, for this voice project, we intend to make it open source. So that is the link for actually accessing this demo. And I hope we'll get some community members to actually join us in actually adding more features to it. So thank you so much. That's it from me.
Thank you, Brian. That was a great presentation. Now we'll have the Ask the Expert sessions. So if the presenters could please turn on your cameras now. And if you have any questions, please ask them using the Q&A feature located on your Zoom toolbar at the bottom of your screen. And the first question we have is for David. I saw that you answered it, David, but can you please describe to us any more information on what factors contribute to the performance scores?
Yes, I can just describe again what we did. So the factors that contribute to the model performance score are all measurable KPIs of a 3D file. For example, the polygon count, mesh count, node count, material count, texture type, texture size, and so on and so on. The overall file size, compressed and uncompressed. And what we did is we created a benchmarking tool which just loaded a very big amount of models and benchmarked these models on different devices, on mobile devices, on desktop devices. And the AI then combined the FPS score and the loading time and the runtime usage with those model typical numbers. And that's pretty much what happened. And now the AI is given a certain amount of information, for example, a mesh count and a material count, and then it sort of estimates on how long the model is going to load in your browser and how good the frame rate will be, and so on and so on. So that's around what we did.
Great. Gustav, does PlayCanvas support other formats other than glTF?
Yeah, we actually do. We support importing as FBX as well, but on the background, it kind of gets converted to a GLB in the end. So internally, we support GLB, but we have a layer that converts it.
Great. I had questions just came in. I believe this was for David. What kind of texture compression is being used? Is it JPEG or KTX2 or?
Currently is JPEG, but we have been working on KTX2 and will be supporting this format in the future as well.
Great. And Gustav, what uses do you see of being able to take the GLBs apart?
Well, we're thinking that you might want to, because GLBs represent the whole scene, you might want to be able to take a GLB scene, like a glTF scene, take it apart, take just a component that you want and use it in your project. So that's kind of one of the big benefits that we see from it. You might not want to have everything in the scene. You might not want to have the lights or the camera. You might want to adjust it to your project. So that's why we thought that it would be a very good idea.
Thank you. David, does the software also deliver the user interface that we have seen in the various videos?
Yes, it does. So the user interface, the software comes with a range of different templates for different use cases, like a user interface for step-by-step manuals, for example, or a user interface for virtual tours. So it's all stored in the GLB file in the extra section, really, to give you all the information that you need to display everything when you load it into the browser.
Cool. Gustav, do you support any vendor extensions such as the Microsoft LOD or the extension image-based lights?
We don't have any plans at the moment to add support for any but the ratified extensions. So if there are going to be any more ratified extensions coming out, we're going to add support for them definitely. But for now, we don't have any plans of adding any of the other ones.
All right, and we're running a little late, so I just want to get one more question in there. David, is there a virtual reality support for the software?
Not yet at the moment, but we're just now working on creating virtual reality support, and within 1 or 2 months, we'll be able to deliver WebXR experiences just over the same interface, which will run seamlessly on virtual reality headset like the Quest Pro, for example.
I had one last one come in from James. Have you had any security concerns exposing models via the 3D viewer? His company has had to come up with a few creative ways to stop someone grabbing it by looking into the developer tools network panel.
Yes. Security in terms of 3D in the web is a very complex subject. There are different measures that you can take to protect your, well, not 3D data, but the information within your 3D data. There is obfuscating possibility, for example, in the tool. You could encrypt your 3D file as well, but it's more about the sum of what you do. There is not that one true answer that will solve all of the security concerns for everyone.
Great, thank you. I appreciate you, gentlemen. Thank you so much for your time today. The presentations were very informative and well done. As a reminder, recording of this presentation along with the slides will be available on the Kronos Group website, and a direct link will be sent to you in a follow-up email. As you leave the webinar, please take a moment to fill out the survey that pops up. Your feedback is important to us to help us improve the. Please let us know if there are other Kronos-related topics that you may be interested in, and thank you for joining us. We hope you enjoyed the webinar and have a great day.
Thank you. Have a great day.
Thank you.